Hi, I'm Pat Merlo from Spot Imaging Solutions, and I'm here today to talk about how to get good digital images from your microscope with your spot camera. And there's four primary subjects that we want to talk about today. And the first one is that you have to start off with a good monitor. What are the characteristics of a good monitor? To me, a good monitor, first of all, should be bright. A dim monitor will always give you kind of a lifeless image, but a bright monitor will be nice and punchy. And then you want a monitor with some contrast. High resolution is really good. There's a batch of new monitors out now that are called Windows 8 qualified monitors that are quite good. They tend to have a nice glossy screen on them, which is a little bit sharper and brighter than a matte screen, which tends to diffuse the image a little bit. And they also have HD resolution, a very high resolution, 1920 by 1080. And they have very good image quality too. I like them. One of the monitors that we've used that we like, and we get a lot of monitors coming through our company, but this monitor is remarkable. The Acer 23-inch monitor is one that we like a lot. Now, one thing that's not obvious to everyone when they use a monitor is the fact that most monitors are shipped from the store, and they're designed to make your Microsoft Office graphics, your spreadsheets, everything look really bright and crisp, and you'll love the way it looks and take the monitor home. But it doesn't always do a great job also on images. Images require a little bit more careful, more subtle approach. So first of all, monitors that ship from the store usually have the color temperature more toward the blue end of the spectrum. And when you look through your microscope, the microscope is not that blue. Also, monitors from the store tend to be very high contrast, maybe too high contrast, where the whites are kind of very white and a lot of detail is lost in the bright areas, and the darks are very dark, and again, detail gets lost in the dark areas. So what we recommend really is one of the major things you can do to improve the quality of your images from your digital imaging is to calibrate your monitor. And this is very easily done with a very simple device that suction cups right to the front of the monitor, and you start the software going and walk away for about 5 minutes, and it goes through and calibrates the monitor for you. It creates a profile stored in the computer and loaded into the graphics card every time the computer fires up, and it puts a more photorealistic mapping into the video card, so that when you take a picture, it has a far more realistic, natural look than it would normally have. So we're going to go on to what creates the image. Well, actually, what gives the image to the camera is the microscope. And again, this is another critical element in the process. Older microscopes with less expensive objectives and poor quality illumination will never give you the image that you will be happy with. So for the illumination in the microscope, we recommend the industry standard Kohler type illumination rather than the less expensive critical style illumination. And you can easily check if your microscope has Kohler illumination. This is the system that also has, in addition to the iris diaphragm and the condenser, this is the illumination that has the iris diaphragm also in the base of the microscope. And then, of course, you have to properly set up Kohler illumination. And it's not obvious how it should be set up. On our website, we have a little tutorial on the proper setup of Kohler illumination. When Kohler is set up, it really helps make your images just stand out. The other thing that's very critical, just like with a camera, is a good quality lens. And microscope objectives come in different qualities and obviously different price points. Plan achromats are pretty standard, and they do fairly well for most visual use, but the camera's more critical. And you're going to find that spending the extra money for plan fluorites, or if you've got the money, plan apochromats will yield far more dramatic increases in the image quality that you see through your camera. Final element between the microscope and the camera is, of course, the video coupler. And we always recommend choosing the magnification of the video coupler so that the image that you see from the camera pretty closely matches the field of view that you saw through the eyepieces. If you go too high in magnification, you end up looking at just the center of the image that you saw through the eyepieces, and you find out that you're starting to magnify the blurriness of the image rather than seeing the overall crisp image that you saw through the eyepieces. So fine details, when they're magnified too much, look a little bit blurry. So for, let's say, a camera with a 2/3 inch chip format, we'd recommend a 0.6 magnification coupler. That would give you a good match. And then we move on to your environment. Now, a lot of people not only want good-looking images, which, you know, you're getting there, but they also want the image on the monitor to look like the image they saw through the eyepieces. And one of the problems that you have is that if your office, like mine, has a northern exposure where you don't get any direct sunlight, but all day long you get the blue northern sky, or in Michigan the gray northern sky, usually in the winter, but the blue northern sky is very blue, but your eye always adjusts for it. So your eye does its own white balance. You pick up a white piece of paper, it looks white to you, okay? That's because your eye is adjusted to the blue light. But if then you swing your head and look through the microscope, boy, that light's going to look a lot yellower than the blue northern sky. And you probably had some experience doing this when you went outside of your house for a walk at dusk. At dusk, you've got the deep blue sky overhead. Your eye adjusts for it. But when you come back home and you look through the window at the lights inside the house, boy, do they look yellow or orange. Because compared to the outside light, that light is very yellow, very orange. So an ideal environment, which not everyone admittedly can arrange, would have a very soft, diffuse light in the room of about the same color temperature, the same yellow or blueness that the light through the microscope has. This way, your eye won't perceive the light through the microscope as being a lot different than the room light, and it won't be mismatched, perceived by your brain. The other thing that is also important is that when you start using the microscope, we want you to, if you have a halogen bulb, run it near its maximum rated voltage, typically 6 volts or 12 volts. And we also like to use a color conversion filter. This is a bluish tinted filter that will change the yellowish light to more of a white, not blue, but a white light. And this gives the camera a better light to work with when it's forming the image. We recommend an 80A if you're using halogen lights that are running at full voltage. This will bring the 3200 degree Kelvin, the yellower light from the halogen, up to about 5,000 degrees or 5,500 degrees Kelvin, which is more like a daylight white color. The other thing we'd like you to have too is a selection of gray filters, also called neutral density filters. Again, this is your brain playing tricks on you. If the image through your eyepieces is a lot brighter than the image on the screen, your eye thinks that it's a different color. A blue that may, through the eyepieces, look like a very bright royal blue on a less bright screen will tend to look, a darker, maybe a drabber navy blue. So what we want you to do is put a assortment of neutral density filters over the light exit port and the base of the microscope to try to match the brightness of the image through the eyepieces so that the brightness is a closer match to the monitor. And finally, what is also a really good idea is that in your Spot software, you have the ability to change the color temperature of the image presented on the screen. And a very good way to try to achieve this match is that when you're looking through the clear area of the slide, you'll see a certain color. It'll either be a nice neutral white, or it may be a little bit beigey or yellowy. And what you want to do then is, in the software, take that color temperature slider and move it back and forth until the background on the monitor screen matches the background in the clear area of the slide. Now, if you do all these things, you'll end up with very nice images and very closely matched images between the monitor and the screen. So, just to review, today we've talked about how to select a good monitor, how to calibrate your monitor, how to select good optics to create the image for your camera, and then once the image is in the software, how to adjust the software and the microscope so that they very closely match. If you have any questions, our tech support people here at Spot Imaging Solutions will be glad to help. Thank you.